In this video, we're going to talk about section 4.3, which is properties of logarithms. Our first formula or thing we're going to learn is change of base formula. So if you have log base a of x and you want to find the approximate value of it because it's not easy to find, you can take log of x and divide it by log of a, and you can approximate that to about 3 or 4 decimal places. So we're going to do some examples. So we're going to say log base 3 of 11. I have no clue how to do that other than use the change of base formula. So we are going to use, oops, if I have the pen, log of 11 and divide by log of 3. You can just type log of 11 and then divide it by log of 3 in your calculator, and we're going to round to 3 decimal places, so it's 2.183. And then the next one, we're going to do log of base 7 of 0.25, so we're going to have log of 0.25 divided by log of 7. If you approximate that to 3 decimal places, that is negative 0.712. Alright, then we want to graph this, y equals log base 4 of x plus 1. So we're going to graph log base 4 of x first. So my x's, I'm going to pick 1, 2, and 4. And then we're going to do the transformation after that. But if I plug in 1 for log base 4 of x, I'm going to get 0. If I plug in 2, I'm going to get 0.5. And if I plug in 4, I'm going to get 1. So then the transformation would be adding 1 to everything. So what I'm going to do is just add 1 to everything. So then I have 1, 1 is a point, 2, 1.5, and 4, 2. There's your graph. So some properties of logarithms. If you're multiplying two numbers with the same base, you can separate them and add them together. If you're dividing, you can do the same thing, except instead of adding, you'll subtract. If you have something to a power, you're going to take that power and put it in front of the log and multiply it at the end. Log base a of 1 is 0, and log base a of a is 1. And then if you have log base a of something equals log base a of something else, you can drop those logs and set them equal to each other. So let's do some examples to expand. We're going to simplify them when we can, but we're not going to solve them because I didn't give you any values for the variables. So we're going to expand these. So since these two things here are being multiplied, I have log base 10 of 10 plus log base 10, and typically we don't write the 10, but in this case we will, just so we know, of z. So that's equal to log base 10 of 10 is 1, and then log base 10 of z is log of z. And then here I have an exponent, so I'm going to put it in front. So I'm going to put negative 3 log base 6 of x. That's all I do for that one. And if you want, you can write the little multiplication sign there, but it's just being multiplied. So, and these log properties also work for natural logs as well. So let's just work with the division sign first. So since it's being divided, I can rewrite it as a subtraction. Now I'm going to work with this first part here, and then we'll deal with the other part. So I can write this as ln of x plus ln of square root of y minus ln of z cubed. And if you can do it in do multiple steps in one step, that's fine. However, I'm going to just show you for now all of the different steps. Then ln of x doesn't change, but then you can take ln of y and then the square roots to the 1/2 power minus ln of z cubed. Now I am going to do both of these exponents at the same time since they're both exponent laws. So then I have ln of x And then that just means I multiply them. So, like that. And there's your answer. So, we just expanded them, we are going to condense them now. So since these are being subtracted, and this thing is in parentheses, and the log's bases are the same, I can write them as 1 log, so log of 4, and then z plus 2 divided by y. And then this one, I have ln of 8 to the 1/3 power plus ln of z to the 5th. So 1/3, 8 to the 1/3, so that's the cube root of 8. So the ln of 2, natural log of 2, plus the natural log of z to the 5th. So then this addition sign means you multiply. So 2z to the 5th is your answer. Alright, the next one gets kind of complicated because we got a lot going on. We're going to start on the inside and then work our way to the outside to deal with that 3. So we'll ignore this 3 for right now. We'll still write it, but we're not going to do anything with it yet. So I'm going to have ln of x squared minus ln natural log of x minus 2 minus natural log of x plus 2. So I just did one thing there, but that's okay. And then the next one, we're going to take 3 natural log of x squared divided by x minus 2 minus natural log of x plus 2. And then since this is also a minus, that means I got to divide again. So 3 times the whole thing, natural log of x squared times x minus 2 divided by x plus 2. So that's a lot to deal with, but we're going to come over here and make it a little bit easier. So 3, and then I can take that x plus 2 and put it up there with that x minus 2. 3 natural log of x squared over x minus 2, x plus 2. And then that 3 is just going to come and be the whole exponent for the whole thing. And you don't have to FOIL things out. You can just leave them. There's your answer. And last view, we're going to use we're going to find the exact value using properties of logarithms. So I can say log base 6 of 6 to the 1/3 power. So then I can separate that and have 1/3 log base 6 of 6, which gives me 1/3. Log base 6 of 6 is 1. So 1/3 times 1 is just 1/3. And then I have log base 2 of -1 plus log base 2 of 16. Well, that's not going to work because log base 2 of -1 doesn't exist, so it's undefined. And then natural log, 3 times the natural log, sorry, I forgot about that one, e to the 4th. So natural log of e is whatever the exponent is, so 4 times 3 is 12. And then last but not least, this one's kind of weird, but it'll be alright. So then we have the natural log of 1 over x to the 1/3, because I just changed the square cube root to an exponent. So then I have natural log of 1 minus natural log of x to the 1/3. So I just separated the division. Then I have natural log of 1 minus 1/3 natural log of x equals natural log of 1 is 0 minus 1/3 natural log of x. So your answer is just -1/3 natural log of x. and that is section 4.3.